Welcome, guys. So today we will be solving an interesting problem, and this problem is again coming from two pointers concept. So the two pointers technique, as we know, like the two pointers technique is something which we can apply only for a sorted array. So whenever you are having a sorted array, then only you can go with this two pointers technique. And this two pointers technique is majorly used for searching an element from an array, or it could be like a string, or it could be a linked list. So this is a technique which will help you to, make execution time between on. It won't allow normally. I mean, if you are applying any naive approach and your algorithm is taking complexity like n square and n cube. So normally, but there are some different problems as well. The problem we'll be discussing right now, that is having complexity n cube in normal approach or naive approach, and with the help of two pointers concept we can make it n square or n square. So at the end, the bottom line of the story is definitely two pointers concept is helping us to optimize our problem statement, and through impacting on execution time, also like space complexity. So time complexity and space complexity, on these both areas they can have a have an impact. So space complexity concern, I mean, from the perspective of space complexity, it normally create O1, so you do not need an extra space, so you can accommodate with constant space only. So that is the beauty of two pointers concept. So let's understand like about today's agenda. So today's problem statement is very interesting because we have been given an array. Suppose this array is in sorted nature. So you can see like that it starts from -1, 1, then 1, 2, then 2, 5, 6, 8, 9, and up to this. So the thing is, it got like, I was just counting 11, 12, almost 12, elements it is having. And sorry, 13 elements we are having, and 12 is the last index. So the thing is, in this case, the examiner can ask, like, you will be given like a target value, and the target value is 70. Now, normally you need to find out a pair. I mean, not pair, a triple. Three numbers you need to find out. For an example, your target value is 70. So you have to find three numbers. So these three numbers can be 6, which is having index number 4. The second number is going to be 9, which is having index number 6. And another one is 55, which is having index number 10. So you need to find out these indices, which is going to represent like what is the number we are picking up, and we are summing to get this target value. So this is the problem statement. This is the problem statement. Now we need to solve this problem. We need to solve this problem using two pointers, because if we go with a naive approach, we need ultimately three for loops, right? We'll be having a one for loop, which is going to be an outer for loop, which will start from I is equal to 1 to n, and j, for every element we will be finding like j will start from I to n, I plus 1 to sorry, I to n. And then we need another variable, another for loop, where we will be getting three pointers, arranging three pointers I, j, k, and with the help of arr I plus arr j plus arr k, we will be trying to determine these three combinations I, j, and k, for which the target value matches. So that is going to be our approach, which will ultimately take n cube complexity. So that's not exactly what we want. So we are actually looking for a two pointers concept. So the concept is, I mean, the way we have created two sum of from an array. I mean, we have been asked to find out two numbers. whose addition is going to be target. So in that case, the similar way we will be going. So for an example, we are having few numbers, like I am just making it a short 2, 5, 9, and 10. So for example, we are having this array, and so at the very beginning, I'm just creating 3 different colors. I'm just using 3 different colors. Our first pointer, which is a start pointer, is going to be over here. The end pointer, which is going to be over here. And we need a pointer, which is basically, sorry, which is going to point this one. Okay, so this is our pointer, which is, you can say, initial. So what is the difference between the start pointer and initial pointer and end pointer? What is the responsibilities of these 3? So if you see, the array is sorted. So if you go from left to right, so left to right, the leftmost pointer and the rightmost pointer is having already a huge value, and that is the extreme value, that is the extreme largest value it is pointing right now for this array, and that is 10. So if you are having sum, suppose you are trying to get a sum, and that sum you are calculating with, say for example, you have this array ERR, and you got start value, sorry, start index, you got I index, initial index, and you got your end index, right? So you are calculating this sum. Okay, fine. Now there might be 2 conditions. One condition is like, there will be one condition when your sum is basically greater than your target, right? And there might be another condition. What that condition is? Your target is greater than sum. These 2 conditions may align. And if sum is equal to target, then you will just return. So if sum is equal to your target, then you will return this pair I, J, K, right? Sorry, not I, J, K. In our case, it is different. We have not kept like I, J, K. Rather, we have kept start, initial, and end. Right? These pairs we will return directly. Right? Now, in this case, when your sum is greater than target, so sum means the calculated sum. This is basically target. This is basically greater than target. That means we need to somehow decrement. If we go with an adjustment, then we need to decrement this sum, right? Suppose sum के value है, यहाँ पर हम लोग we are trying to find out, say for example 12. We are trying to find out 12. 12 is our target, and we calculated like at the very beginning we are having 10, right? So 10 is basically lesser than 12 is greater, so it is coming under these conditions. When our target value is basically having more more value, so target value is 12 and our sum is basically 10, right? 10. So in this case we need to increment our sum. So which pointer is responsible for incrementing this sum? If we just forget about this first pointer, think about these 2 pointers, this one and this one. If you just think about these 2 pointers, why will be forgetting this first pointer? I am coming back. I'm coming into that part. But initially you think that it's a simple problem, and that problem is starting with this. That is, you are having this, and this is basically a constant thing. So within this pointer is basically responsible to make sum up, and this pointer is movement is responsible to make sum down, because this pointer only can move in this direction. In this direction, when the pointer is going to move, it is going to pick the elements which is having lesser value than currently it is pointing the value. Currently it is pointing the value that is 10. So next time if it is decremented, then it is going to point 9. So 9 is lesser than 10. So this pointer is basically responsible. This pointer's movement is basically important to decrement the sum. And this pointers, in this case, if this pointer gets incremented, then it is going to contribute for enhancement, means for increment of our calculated sum. So that's why I'm making it up. So it's down, it's up. So in this case, we need to increment our sum because calculated sum is 10. We need to increment. So what we are going to do, we will just increment this pointer I plus plus, right? I plus plus. On the other side, if our target value is basically lesser than the sum value, that means we need to decrement our sum value. So who is responsible for decrementing? This end pointer. So end pointer needs to be decremented, because this is basically, this movement of this pointer is basically reducing this sum value. This movement of this pointer is basically, so this is reducing. This movement is basically improving our sum value. That means incrementing our sum value. So that is the basic condition. Now you guys will ask me that, yes, you have kept this pointer intact. You have not changed this pointer. Why? Because this pointer is basically will be on loop. So for is equal to 1, we will be calculating with these two pointers. For s is equal to 2, when s is equal to 2, we will be calculating starting our next pointer, right? So when s is equal to 2, so s is going to point over here, and this I is going to be shifted. So I is going to point over here. When s is equal to 3, sorry, s is equal to 2, s is going to point over here, then I is going to point over here. So in this way, actually, we will move. And so that is the, you can say like this is kind of an external for loop. And this for loop actually says, yes, I'm keeping my pointer over here and I'm allowing these two pointers to play among themselves and try to find out the combination. So you can say like my first treatment will be true like when I is equal to 1, when I is equal to 1, first treatment, in the first treatment, s is equal to 0, and n pointer is basically is equal to n minus 1, right? N, where n is the total array length. In the second treatment, we are having s is equal to 1, and I value will start from 2, and e value will be from n minus 1. In this way, it will move ahead, right? So that is the basic fundamental stuff or technique we can use when we are trying to find out three candidates from this array whose summation is going to be with or equal with the target value given from user's end. Now this, naturally, this is having O(n) square, complexity, as it is, you can see like, you can say like we have used two for loops. So if we just come into the program, you can say very simple program. It doesn't have much complexity. So this is the function which we have written over here. We are taking an array. This is our array size. This is our target value. So in this case, the result is basically we will be returning, and that is nothing but an array which is having three candidates, three elements. So these three elements are nothing but the indices. So as we mentioned in the diagram itself, like when we will be falling in this case, like when the sum and target value will be equal, in that case, we will be returning this set. So here, before moving, when we entered into the for loop, you can see the for loop starts I is equal to 0. So I is our basically S. In the diagram, we have written S, that is basically I. And you have seen like there are two pointers. J starts from I plus 1 and K is always pointing to the last value. So when S is equal to 0, then also K here, which we have printed as E, that is end pointer, that is also n minus 1. Even when S is equal to 1, then also E n minus 1, but I is equal to S plus 1. And that's why as is S, it's pointing to 1, so I is going to be 2. So the same case, in this way, we will move ahead. So this is the basic initialization of our pointers. These are the two pointers, and that is going to take the charge while another pointer is fixed. So that's why this is truly comes under these two problems, sorry, two pointers technique. So these two pointers are playing the role or playing the pivot role. So base condition, as we know, like j cannot be k, j cannot be k cannot be greater than j. K is basically our end pointer. End pointer cannot move beyond j. So when k is this loop will valid till that time when k is greater than j. So this is our terminating condition, which is very important condition. Another terminating condition is this: whenever we are having sum is equal to target, we are actually getting out of this loop. So that is perfect. Now in this case, when sum is equal to target, we are populating the value or indices of I, j, k, and after that, if the sum, as we mentioned, sum is greater than target, that means we need to reduce sum. So end pointer is responsible for this reduction. So we are decrementing these pointers. And in other side, when the sum is basically needs to get increment, so j pointer is responsible to make it increment, and we are returning this value finally. So suppose in this case we are having, if you just come to the driver's code, this is the array we have used, and we want to find out 70. So if we just run it, we can see the answers, and the answer is really good: 4, 6, 10. So fourth location 0, 1, 2, 3, 4. Fourth location we are having 6. Sixth location we are having 9, and we are having 55 in the 10th locations. So 70 is the answer. So it's correct. Hope you guys enjoyed this session. So if you have any question, you can ask me into the comment section. Thank you so much.